Right, so we're almost there, solving trig equations using trig identities. Right, so there are three types of ones that we can solve here using trig identities. Okay, so the first type that we have is solving when we are going to be using the fact that cos squared x plus sine squared x equals 1 in our equations. So we're going to be using this trigonomic identity. This is the one that we knew at National 5, so you need to remember. So it's the one that most often at higher people forget about because it's not given on your formula sheet. So it's using that trigonomic identity, rearranging it to be able to find a quadratic trig equation to solve. So for example, if we have 5 sine squared x degrees minus 2 cos x minus 2 equals 0. I'm going to solve this between 0 and 360. Right, so you can see there, just looking at it to start with, that we've got a squared, we've got a cos, and we've got a number. So we're going to end up with a quadratic here, but with having sine here and cos here, there's nothing we can do at the moment with it. Right, so it's this term here, our middle term, the one that's just got the cos in it, that is going to tell us what we do with this. So we're not going to try and change this. It's this, the bit with the squared, that's got to change, because there's nothing we can do to change that cos x, but we can use our identity here to do something to this sine x. So if we take our identity, cos squared x plus sine squared x equals 1, or it could be sine squared x plus cos squared x equals 1, same thing, just putting them around the other way. Because when we add, it doesn't matter what order we put it in. So we want to replace that sine squared x, so we're going to have sine squared x equals 1 minus cos squared x, because I've taken away cos squared x from each side. So now it's about substituting in and solving. And nothing, once we've done this substitution and our rearranging, is new. Okay, so we get that. So we multiply out our bracket. So we get 5 minus 5 cos squared x minus 2 cos x minus 2 equals 0. So it's perfect. This is what we want. We want it to have no sine squared x anymore, no sines at all. It's all cos. Okay, so our second type is when we are going to be using our cos 2x identities. Okay, so the ones that we're going to be using are either that cos 2x equals 2 cos squared x minus 1, or that it's equal to 1 minus 2 sine squared x. Okay, so the third identity isn't going to be helpful for solving these trigonometric equations because we need to have it all in one type of trigonometric function, so either all cos or all sine. So having the cos squared minus sine squared isn't going to help us here. Right, so we'll do an example of this. So we have 3 cos 2x minus 10 sine x plus 1 equals 0, and we're going to solve that between 0 and 360. So same as the first functions, we're looking at the sine x to help us decide. So we're looking at the function that doesn't have the 2x or doesn't have the squared, or whether we're looking at this one that we can't change, which is at sine x. So that means that we've got to change the cos 2x, and we're going to have to change it into sine x. So if we replace that in with the one that includes sine squared x, we get 3 brackets 1 minus 2 sine squared x minus 10 sine x plus 1 equals 0. Multiply our brackets, we're going to get 3 minus 6 sine squared x minus 10 sine x plus 1 equals 0. If we sort out our numbers, we're going to get minus 6 sine squared x minus 10 sine x. 3 plus 4 equals 0. Our sine squared x term is negative, we don't like that, so we can change the signs of everything as though we're moving it to the other side. So we get 6 sine squared x plus 10 sine x minus 4 equals 0. Okay, and then we can factorize that, so we get 6x squared plus 10x minus 4, replacing where x equals sine x. So when we're factorizing this, we can take a common factor of 2 to give us 3x squared plus 5x minus 2. So we have that 2 at the front. Our 3x is going to have to be 3x and x, and our 2 is going to have to be 2 and 1. And we are going to want to have minus 2 and plus 1, because that's going to give us minus 6x plus 1, so that's not what we want, is it at all? We want these signs to be round the other way, because we want plus 6x and we want minus 1. Right, so putting this into here, back replacing it in, so we get 2, 3 sine x minus 1 times by sine x plus 2 equals 0. So therefore we've got 3 sine x minus 1 equals 0, or sine x plus 2 equals 0. So here when we rearrange, we get sine x is equal to 1/3. So cast diagram, ASTC. So sine is positive in the first two quadrants, and our relative acute angle is going to be the inverse sine of 1/3, which is 19.5 degrees. So that gives us that x is equal to 19.5, and 180 take away 19.5. So we're going to get 19.5 and 160.5. Okay, so that's our answers for that part. And then our other one, we rearrange to get sine x equals -2, and then we therefore no solution as sine x has to be between -1 and 1. Okay, right, so that's the second type. So now on to the third. Right, our third type is to use sine 2x equals 2 sine x cos x. Right, this isn't going to give us a quadratic like the other two. So these are a little bit more simple to solve. They're giving us linear equations which we solve by finding a common factor. Right, so example, we are going to do 2 sine 2x plus 3 sine x equals 0. So we're going to substitute in the fact that sine 2x is 2 sine x cos x. For this one, there's no other thing that we can substitute in. There's no choice to make. This is our only option. So 2 sine x cos x plus 3 sine x equals 0. So there shouldn't be an equal sign here, apologies. So we get 4 sine x cos x plus 3 sine x equals 0. So we can take out a common factor of sine x. And so then we get left with 4 cos x plus 3 equals 0. So here we get that sine x equals 0. So sine x equals 0, so therefore this gives us the answers x is equal to 0, 180 and 360, assuming we're going between 0 and 360. And then our other bracket gives us 4 cos x plus 3 equals 0. So we rearrange and we get cos x is equal to -3/4. Okay, so cast diagram again. It's negative, so it's in our second and our third quadrants. And our relative acute angle is the inverse cos of 3/4, which gives us 41.4 degrees. So therefore x is 180, take away 41.4 and 180 plus 41.4, which gives us 138.6 degrees and also 221.4 degrees. So for this answer we get 5 solutions. And that's us for using our trig identities, remembering that the cos 2x ones and the sine 2x ones are given to you on your formula sheet, but the first identity that sine squared x plus cos squared x equals 1 is not given to you anymore. It's expected for you to know it because it was at National 5 level. Okay, thanks for watching. Please like, comment and subscribe if you've got anything you need to ask. Write it in the comments and I'll clarify if I can. Thank you for watching.